I, j, k are unit vectors in the direction x, y, z axis respectively, and every vector x, y, z can be written as xi plus yj plus zk. In this example, we are given A is the point 2, minus 2, 1, B is the point minus 2, 1, 1, C is the point h, 3, k. We also find unit vector parallel to A, cap A. And then after that, find two vectors parallel to A, having magnitude 18. And part 3, find the values of h and k such that A, B, C are collinear. To find cap A, first you find magnitude of A. Magnitude of A will be square root of 2 square plus minus 2 square plus 1 square. So it's just square root of 9, which is 3. So with that, cap A should be just 1/3 of 2 minus 2, 1. And what you want is 18, length 18 in part 2. Part 1 cap A is just 1/3 2 minus 2, 1. And part B, right, part 2, right, is just 18 cap A, or minus 18 cap A. You want two vectors parallel to A, so it can be opposite direction. So cap A is 18 cap A is parallel to A. Then minus 18 cap A is parallel to A also, but opposite direction. This is opposite direction. Opposite direction. Then this is same direction. So that means it's just 18 of cap A, which is 1/3. Then 2 minus 2, 1. So cancel is 6. So it gives you 12 minus 12, 6. So this is one answer. Then the other answer is negative 18 cap A. So this should give you minus 12, 12, minus 6. Next, we will look at part 3 to find the values of h and k given that A, B, C are collinear. And to solve this, right, you will make use of the fact that if 3 points A, B, C are collinear, then AB parallel to AC and also parallel to BC. And with that, right, you can use the result in slide 15 and say that if two vectors are parallel, then A must be a multiple of B. So with that, it means you can actually say this AB is a multiple of AC. You can also say AB is a multiple of BC and so on. So that's what you're going to do to find H and K. So to find H and K, given that A, B, C are collinear, we can say AC is parallel to AB. So we can say vector AC is a multiple of vector AB. Vector AC is vector OC minus vector OA. Then is alpha vector OB minus vector OA. OC is H3K. OA is given to be 2 minus 2, 1. Then equal to alpha and OB. OB is minus 2, 1, 1. Then OA is 2 minus 2, 1. So we can say H minus 2, 5, and K minus 1. You simplify this part, it will give you h minus 2, 5, k minus 1, then equal to alpha. You simplify this, you give you negative 4, 3, 0. And then you can compare components. If you compare the z component, so we compare z component, then you'll find that k minus 1 must be 0. This is actually minus 4 alpha, 3 alpha, 0. So we get k is 1. Then you compare y component. 5 is 3 alpha. So alpha is 5 over 3. And then you can compare x component. If you compare x component, then h minus 2 must be minus 4 alpha. Alpha we just found is 5 over 3. So it will be minus 4 times 5 over 3. And then you can say h will be minus 20 over 3 plus 2. There's a minus 2 on the left hand side. There's a minus 2 on the left hand side. You bring it over, become plus 2. So we get h will be minus 14 over 3. So the answer is h is minus 14 over 3 and k is 1. You can check your answer. So after you have found h is minus 14 over 3, k is 1. Because you are looking at ABC collinear, then we know that AB, vector AB, AC, BC must be all parallel. So that means you can look at your vector AB, that means you can sub h as minus 14 over 3, your answer, k as 1. And then you work out vector AB, vector AC, so you work out vector AC, you work out vector BC, it must give you parallel vectors.